So let's start chapter number 9, basic concepts of hypothesis testing. So in this chapter we are going to learn how to perform a hypothesis test for one population mean. And what we are going to do, we are going to learn first basic concepts, right? And this is a chapter we were all waiting for, a kind of a chapter we were all waiting for, in a sense that everything we have learned so far will come into an existence. We will see the real use of everything when we learn this chapter. And in this particular video, I'm not going to tell you how to perform a hypothesis test, but rather I will show you what are the basics of performing a hypothesis test. What are the basic concepts? What are the basic ingredients you need to learn? So let's start. So first off, what is a hypothesis? It's a claim or a statement or an assertion about a property of a population. You give a statement or you give a certain claim. You claim something about the population. That can be a population, that can be something about the population mean, that can be something about the population standard deviation, but that can be something about the population proportion. But in this chapter, we will only talk about the population mean. That's a concept. We are testing the hypothesis for one population mean. Right? What is the example? The mean monthly cell phone bill in this city is $42. We are having this claim. We are claiming this, right? This is a claim about the population, Such a claim is called a hypothesis. So first, what is a null hypothesis? Null. So every hypothesis starts with a null hypothesis, right? What is a null hypothesis? A statement that the value of a population parameter, and in this case, it will be a population mean, population parameter, in this case it will be a population mean, such as a mean, is equal to, that's important, to some claimed value, right? For example, let's see that. For example, look at that. The mean diameter of a manufactured board is 30 mm, right? We are giving a claim about a population mean that it is equal to 30 mm, and we denote a null hypothesis by this symbol H sub 0. H for hypothesis and 0 for initial, for the null hypothesis. That's initial hypothesis, the null hypothesis, right? So the diameter of a manufactured board is 30 mm. I can also write it like this. Let me go to some this new board. We start launch a new board. So what I can write here, I can write, okay, I have a null hypothesis H sub 0, and we are claiming that the mean is equal to 30 mm, right? So this is a kind of a statement. This is a kind of a statement I'm giving about the population mean. This is a mathematical way. This is a mathematical way of writing the null hypothesis. This is a mathematical way of writing a null hypothesis. H sub 0 is, we are saying this is a null hypothesis, and this is that statement. So let's see what else we have about the null hypothesis. We begin our hypothesis test to begin with the assumption, with the supposition that the null hypothesis is true. It's always about, this statement is always about the population parameter and not about the sample statistics. What I mean by that, this statement will always be that mean is equal to some value, mean, some value. It will never be, this is a population mean. This will always be like this. It will never be such a statement, that the sample mean is equal to some value. This will never be. This will never be such statement. Never. It will always be a statement about the population parameters, not a sample statistic. That's what I'm trying to tell you. Refers to the status quo. This null hypothesis always refers to the status quo. What is right now? What is the status quo? What is the historical value? And it always contains an equal sign or less than an equal sign or greater than an equal sign. It always contains one of these symbols. And I will tell you later that we will, if we have this one, less than or equal to, greater than or equal to, we eventually convert it to equality. I will tell you the reason for that. And it may or may not be rejected. When we have a null hypothesis, we have two options. We either reject the null hypothesis, or we say, okay, we do not reject the null hypothesis. I will talk about this in detail later, right? So this may or may not be rejected. So now let's see what is an alternative hypothesis, and it is represented by H sub A, right? H sub A. What is an alternative hypothesis? Alternative hypothesis is a statement about the population parameter that the parameter has a value that somehow differs from the null hypothesis. It's different from the null hypothesis, right? Somehow different, right? Maybe less than, maybe greater than, or may not be equal to. I will show you what I mean by that. For example, the mean diameter of a manufactured board is not equal to 30 mm. You remember in my previous example, let me go to that board. In my previous example, you remember that I talk about that the null hypothesis is a statement that the population mean is equal to some claimed value. So what is an alternative hypothesis? It is H sub A for alternative, and this says mu, the population mean, is somehow different from this value, is not equal to 30 mm. Right? That is the statement regarding the alternative hypothesis. Remember, some textbook use the word H, the letter H sub A. Some textbook use the this notation H sub 1. Like some textbook use H sub 1. Some textbook use H sub A. So I will use this H sub A. So this is a statement saying that the population parameter has a value somehow different what we are claiming in the null hypothesis, right? So we use the symbol H sub A, I already told you, to represent the alternative hypothesis, right? H sub A. And it never contain an equal sign or less than an equal sign or greater than equal to sign, but rather contain a less than symbol or a greater than symbol or a not equal symbol. This is very important that you understand this concept, that what symbol it contains. And from these symbols, we're going to identify which one is a null hypothesis and which one is an alternative hypothesis. This thing will become more clear when I give an example. Remember, whatever I'm discussing right now will make more sense to you when I take a real example, okay? So don't be disheartened if you're not getting right into it. So H sub 0 is the hypothesis of no change. This is the null hypothesis. That's why the no change, look at the word no change and null. And HA is what you want to prove. The alternative hypothesis is actually the hypothesis which you want to prove. It's actually the opposite of the null hypothesis. Opposite of the, whatever the null hypothesis is, it's exactly the opposite of the null hypothesis. Very important that you understand this one. It may or may not be proven. Remember, in the null hypothesis, I told you it may or may not be rejected. But in this situation, it may or it may not be proven. Is generally a hypothesis that researcher is trying to prove. So if we want to prove something, we pose this, we pose our hypothesis test in such a way that this that something which we are trying to prove, it results as an alternative hypothesis. So this is actually the hypothesis which the researcher, which can be you, which can be me, is trying to prove. Hypothesis test. So what comes to our mind now? What is a hypothesis test now? It is a procedure, a method for testing a claim about the property of a population. We have a claim about a property of a population, and we are trying to prove that. We are trying to test that claim. We are trying to test that statement. We are trying to test that assertion regarding the property of a population. Now let us see how many types of hypothesis tests are there. Remember, there are 3 types of hypothesis tests, right? So let's see what I mean by that. A statistical test is, number 1, left tail test if the alternative hypothesis state that the parameter is less than the value claimed in the null hypothesis. So such a test is called a left tail test, right? If the alternative hypothesis contains a less than symbol, then it's a left tail test. I will explain this further. Let me first complete this one. An alternative a hypothesis test is a right tail test if the alternative hypothesis states that the parameter is greater than the value claimed in the null hypothesis. So it will be a right tail test if the alternative hypothesis contain a greater than symbol, right? I will show you in a minute in the detail. The picture I will show you. And a hypothesis test will be a two-tailed test if the alternative hypothesis states that the parameter is different from, not equal to, value claimed in the null hypothesis, right? It's different from mean we don't know, is it less than or is it greater than? We don't know that, but we just know that it's different from that. Then we make it as a two-tailed test. So I will show you what I mean by that. Let me show you the picture and you will probably understand it better. Let's understand that. So the hypothesis test will be a left-tailed test. Let me write that. It's a left-tailed, right? If the alternative hypothesis, it's always about the sign. It's the alternative hypothesis contains a less than symbol. Always a less than symbol, then it's always a left tail test. L for left and L for left. And how it look like? It look like this. Left tail test, this is the normal distribution, and this is this, and this is the left tail test. This is the area. I will talk about this area. This is in the left tail, the rejection area. I will talk about that later, is in the left tail. Right? So such a, if the alternative hypothesis contain a less than symbol, it's a left tail test. So it will be when it will be a right tail test, let me tell you, it's a right tail test. A right tail, it's also called the upper tail test, right tail test. One, when the alternative hypothesis contains a greater than symbol, right? If an alternative hypothesis contain a greater than symbol, it will be a right tail test. And how it look like in the picture, let me show you. Let me make a normal curve here. This, and this is the area. This is the rejection area, or the area in the right tail. All the area is in the rejection, in the right tail. I'll talk about that, what I mean the rejection. So if you don't know what I'm talking about, so just the right tail. This is the right. So this entire area, in this case, we call this as alpha. I will talk about that later. It's called the significance level, right? And this is also alpha. Now, when the hypothesis test will be a two-tailed test, two-tailed test, this is the third one. A hypothesis test will be a two-tailed test. It's called two-tailed, right? If the alternative hypothesis contains what? It contains not equal symbol. If it contains a not equal symbol, this is an example. This is an indication of a two-tailed test. And how it look like? Let me show you. This is the normal curve, like this, and a two-tailed is like this. So these are the two tails. And the alpha is equally divided in these two tails. We will talk about that later. This is the area in the two tails. So the total alpha is divided into two in these two tails. So this is the half of the alpha, and the half of the alpha is here, alpha by 2. So how you can determine, how you can identify it's a left tail test or a right tail test or a two tail test, it's all about the alternative hypothesis. If the alternative hypothesis has a less than symbol, it's a left tail test. If an alternative hypothesis has greater than symbol, it's a right tail test. If it has a not equal symbol, two tails up. Thanks for watching. Let's understand what is the basic idea behind the hypothesis testing. I'm just telling you the basic idea. I'm not telling you how to perform a hypothesis test. So this section must be studied with a general idea. So what we test a claim about the population parameter based on the sample statistics. So what we do for this purpose, we collect a sample, right? If our sample data do not support our claim, we reject our claim. And if our sample data supports our claim, we say we fail to reject our claim, right? We fail to reject our claim. And note that we are not saying we accept our claim. So remember, we either reject our claim or we fail to reject our claim. We never say we accept a claim. The reason for this purpose is that accepting something is a stronger word, and we, on the basis of some sample evidence, we cannot give such a strong statement about a claim. So we say either say reject claim or we fail to reject the claim. Let's understand this with the help of an example. Let's see. This is the, let's say we have this a population. This is the population of people, right? The population consisting of people. And we have a claim about this population. The mean age is 50. Okay, we have a claim. We have a claim. Somebody told us, or we have a history of that. We know that the population of this, the mean age in this population is 50. So we want to test this claim. So what we do, we select a sample. We select a sample from this population. And what can happen? What can happen that let's say our sample data. Let's say we collect a sample and our sample data give us the mean age of 20 years, right? Let us suppose, for the sake of discussion, 20 years. Now look at that. Our population age was 50 years, and our sample is saying it's 20 years. Now this 20 years is way away from the 50 years, right? So our sample data do not support our claim. So what we're going to do, we're going to say, sorry, our sample data do not support our claim, so we reject our claim. We reject our claim. In this situation, I'm saying, we reject our claim that mu, the mean age of this population is 50. That's a one scenario. This is the one scenario. What can happen in the second scenario? Let's say in the second scenario, we still have the population age, the mean age is 50, and let's say the sample data comes out to be, let's say, 48 years, right? Let us suppose for the sake of discussion. Now look at this, 48 years and 50 years. There is a very little difference. Our sample data supports our claim. Why? Because there is a very little difference between the population age and the sample age. So you could say our sample data do supports our claim. So we say we fail to reject our claim. In this situation, we say fail to reject. We fail to reject our claim, right? So we stay where we are. We accept. We don't do any changes. We say, okay, where we are here, what we have the same statement. The mean age is 50 because our sample data do support our claim. So we are not in a position to reject our claim. So that's the basic idea. So in this short video, I told you what is the idea behind that, what is the process behind that, what is the mindset behind that of testing the hypothesis, right? How the idea of hypothesis testing work, right? So I hope you understand that. Thanks for watching.